Hello everyone. Hi Arno. Hi Igor. Hi Mario. Thank you for joining first Enapter YouTube live stream. Let me first introduce myself for those who don't know me. I'm Nikolai Krasko and I'm representing software team of Enapter located in St. Petersburg. We're also doing this stream from my home, from St. Petersburg suburbs, where me and my wife are keeping the lockdown. Today's live stream will help you to know more about Enapter EMS components. You will see the demo of how Enapter technologies enabling integration for monitoring and control for solar setups. Also, I have a laptop here, and I will answer all the questions you will leave in the comments on the right side in the bottom of the screen. At any time, if you like this stream, don't forget to click thumb up and subscribe to our channel. You will receive the instant updates of our further videos and live streams. Okay, I see that the number of viewers is growing. That is great. Welcome for everyone who just joined. As I already told, don't forget about likes and subscription. And I think we can already start. One of the most common questions I asked, what is EMS? I believe many of you already know, but I definitely would like to start with this question. The EMS stands for Energy Management System, and in general, this is a combination of hardware and software which helps grid operator for medium and large-scale energy systems or homeowner for private energy systems to monitor and control energy system and as a result optimize the performance of energy generation and consumption. Today, the number of private renewable-based energy systems, we also call them microgrids, is growing. With this trend, the fragmentation of equipment for inverters, batteries, electrolyzers, fuel cells is growing as well. In the end, all this equipment needs to be working as unified energy system. The inconsistency of energy resources such as sun and wind also opens a question of predicting the energy yield and demand using artificial intelligence and machine learning algorithms. Enapter EMS is designed in the way of blocks, which are helping us to address the problems with data acquisition, monitoring, control, and automation wide range of energy devices, including our electrolyzers and third-party equipment, which supports different communication protocols. And also, our EMS allows to enable intelligence for energy systems. You should already see the architecture of our platform on the screen. The first and very important block is our universal communication module. This is a tiny DIN rail mountable device, allows to translate protocol of energy devices into the common language. And also it enables wireless communication for the device. As you may see, we have a wide range of these modules which supports different protocols. Analog and digital inputs, analog outputs, relays, Modbus, RS485, RS232, Ethernet, HTTP, CAN, SNMP. Any protocol can be supported. The great thing about these modules is that the hardware is standardized. This helps to improve functionality with the seamless software updates. In our today demo, we will use our ENP RS232 module, which uses the serial port communication to connect to the hybrid solar inverter with the watch power protocol. The box with the module contains the module itself, the cables, antenna, and quick start guide. The second component of our software setup is open source gateway, which is based on Linux operation system. It runs on a standard Intel-based hardware, and in my case, I use Intel NUC platform. You can see it on the DIN rail in the cabinet behind me. The role of this device is to aggregate the data from all universal communication modules on site and control logic of energy systems with rule-based engine. The rule-based engine is a very unique tool, which allows system integrators to set up their own custom if-then-else logic according to the needs of the customer. For example, for our setup, we can make the rule to switch off energy output from battery to grid if voltage on battery is dropped below 25 volts. This will help to save the battery life from full discharge. Or making simple time-based rule to charge batteries only from solar during daytime will help to ensure we don't use expensive grid energy for this purpose. With such approach, we can set up any logic, from simple to very complex. In case if standard conditions are not enough, integrators are more than welcome to set up more complex logic using Lua customization toolkit and command line interface of our gateway. I would like to mention that the gateway is optional device and only needed for advanced logic, as well as mitigating internet connectivity issues on site, as it buffers and compresses all transmitted data. For our user-oriented case today, all the logic will be handled by EMP RS-232 module itself. The next block of our EMS is Enapter Cloud, which receives all data from gateway and devices and allows to store, visualize it, and use it for training of artificial intelligence algorithms. The data can be accessed in the either real-time or an on-demand way for performance tuning, demand consumption, and errors prediction. The last component, which makes the system even more friendly, is our mobile application. It is available in Google Play and Apple App Store and allows users to monitor the system and integrators to set it up in a few easy steps by just scanning the QR code located on the device. For example, on the EMP RS-232, the QR code is located here on the right side. The mobile application allows monitor, control devices and receive alerts about issues with push notifications. This can happen everywhere in the world in a very secure way. Also, for this demo, the application will help us to set up the basic rules. In general, all EMS have the same architecture. However, Enapter EMS is focused not only on integrator, but also on end users of energy systems, especially for microgrids. In case if you have any questions, don't forget to put them in the comments. I will definitely address the most interesting of them after the demo. Now, I would like to introduce my microgrid setup, which you might already have noticed on the back of me. So last summer, I decided to put some efforts for building my private solar power plant. The main purpose was to create a real test site and as a result to get a setup which can handle few real use cases. The first use case is that my outdoor lighting should use the batteries during the nighttime, while the batteries should be charged during the daytime. The second use case, I would like to use this outdoor power outlet to charge my lithium battery-based tools, which I use in time to time in the garden or at my home. The last case is that my all security cameras and internet connectivity, the router, must be powered primarily from the solar and be backed up by the grid and batteries in case of any outages. For this purpose, with the help of my friends, we've installed 1.2 kilowatt of photovoltaic panels and assembled the 2.4 kilowatt microgrid based on MPP solar inverter. Those inverters are hybrid, means that they can produce AC from solar, grid and battery. And also they have a built-in MPPT charge controller which works from PV and charge controller which works from grid. The size of this device is also make it a good choice for the homeowners and small setups. In general case, to control this inverter, you should use the display and buttons on the front panel. Or alternatively, you can use a Windows-based application, and both options are not so convenient. And the bad thing that they don't provide any automation possibilities and remote monitoring. Therefore, we decided to use our EMP RS-232 module and create a support using our Lua customization toolkit. And now I would like to show how it can be easily installed. For installation, we will require the screwdriver, the module, the cables, and antenna. The advantage of RS-232 module is that it can be powered with 9 to 70 volt DC, making it perfectly suitable for the renewable setups, as it allows direct connection to the battery, avoiding additional power supply. My battery array here is 24 volt, so I will connect the module directly to it. This approach is very practical, as it helps to identify issues in case inverter will shut down because of the error. The module will still be able to send the reason of the problem to the cloud as it powered independently from AC load. So the setup is done in a very few simple steps. I will go to another camera. So what we need to do, the first thing, we need to prepare the cables for the power. So just a second, there is a small issue. Okay, so sorry for the technical issues. So we finally managed the camera. So we stopped that we need to prepare the cables for the plus and minus to power the module. So what I will do, I will screw the terminal block, screw these cables into the terminal block of the module. It will be much more convenient for me to do it in my hands rather than on the DIN rail. I will also connect the antenna to the module. And the next step will be to put it on the DIN rail. So I have one spare unit here, so I will connect it here. It's done like this. As I already told, I would like to power this module directly from the batteries. So you can see the terminal blocks here, red and gray. Welcome back. Sorry for these technical issues. Actually, today in St. Petersburg we have a very shiny and very hot day. So outside the temperature is around 31 degrees, and because we were using the very high quality preset for the video encoding, our laptop is overheated and the problems with the streaming happen. So let's continue where we stop. so I will switch to another camera. So here we stopped on connecting the power to our module. So I described that I have these terminal blocks which are sourced directly from the batteries. I already using them to power the DC load. So for example, I have this battery shunt which is powered directly from it, and I will connect our module there as well. So it's done in a very easy way. So I'll check that the cables are right. So the red one is plus. I connect it to the red terminal block. And the blue one I will connect to the gray one. I'm not sure you can see this, but the LED, the green one, started to blink. This means that the module is trying to connect to the cloud, but it will not be able to do because we did not perform the setup. We will do this later. When the module is connected, the light is steady green. So the last thing we need to do is to connect the module with serial cable to the inverter. So what we will do, we will plug it in here, and we will plug it into the module, to inverter. That's done. The physical setup is done, and now it's time to make a connection to the cloud using our application. So what I will do right now, I will connect my phone to this stream so you can see what is happening on my device. Okay, so now you can see my screen. So the first thing I need to do is to download the Enapter application. So to do that, I will launch the Play Store and I will install the app. For Apple devices, you can do the same by using the App Store. Now the download takes some time. So now I will open the app, and the next thing I need to do is to log in into the account. I already have an account, but if you don't, you need to create it using the app, or you can use our web application. So I'm logged into the account. The next step will be to create the site. The site is actually a location name which will keep all my devices. So for this exact demo, I will name it Enapter Live Demo. And location will be the St Petersburg. Sorry, I can't see the too shine. Okay, so the site is created. As I mentioned previously, every device came with special QR code, which is sticked on each module. and we've seen that this is sticked on the right side of our EMP RS-232 module. So we will use this QR code to connect to the cloud. So I will disconnect shortly from DIN-Rail the module, and then I will press the Add New Device button. The application is asking for the permission for the camera. I will allow it, and then I will scan the QR code. So right now, the application is decoding the data which is stored in the QR code, and it enables the secure connection to EMP RS-232 module via the wireless communication. So the next thing we need to do is to set up the Wi-Fi connectivity. Oh, just a second, the app disappeared. Just a second, I will connect it back. Just a second, still trying to connect. Okay. Okay, so the app is back on the stream. So I will continue. Okay, so right now we are stopped on making the wireless connection to our EMP RS-232 module. So for this case, I will enter the name of the network, and I will enter the password. Okay, so right now the application is using the secure connection and sending all the required settings to my EMP RS-232 device. One of the most important steps is that this secure exchange includes the generation of unique security certificate, which ensures that all data is authentic and safe. So the configuration is finishing. And now we can go to the dashboard. So what we can see on the dashboard. For this particular inverter, the dashboard includes the main metrics which are important for it. So the first one is the most important are charger and output source priorities. So as you can see, both of them are set to utility first. This means that at the current moment, my microgrid doesn't utilize the renewable energy to charge the batteries, as well as we don't use renewable energy to power our AC load. The other important metrics are battery voltage and the AC output profile for last 24 hours. For advanced user, we also have the detailed information on the charts with all metrics which are available for this inverter. And advanced users can check them in the app. So right now we don't have much data here because we just connected the module. The next thing which I would like to show you is how the automation works. So for my case, I would like to set up the simple automation to to charge my batteries during the daytime, as well as use all excess power for my AC load. But during the nighttime, I have a night rate for the grid. And I would like to make my microgrid more balanced. Therefore, I will switch the AC output to the grid during the nighttime. And I will show you how I can do this. So I will go to the source priorities and I will start adding the rules. The first rule will be for the charger source priority. So I'm clicking to add the charger source priority rule, and then I'm choose solar only, because I want to charge my batteries only from solar, not utilize the grid. The next step, app is asking me which voltage on the battery should be when this rule is applicable. I would like to use this rule at any battery voltage, so I'm skipping this step. And the last step for the rule is to choose the range when the rule will be enabled. So the range starts from 6 a.m. in the morning, when the sun is starting to shine, and finish at 6 p.m. I'm checking the rule is correct. We set up, this is for charger, and the next rule we would like to add for the output for the same time frame. So output source priority should be set to solar first for all battery voltages, and the time frame is from 6 to 6. Okay, and the last rule, as I already mentioned, I want to make my night tariff to balance the microgrid. So I will make the output source priority to utility first with any battery voltage, to start at 23 o'clock and end at 6 in the morning. Okay, so the rules are created. Now I need to apply them to the module. So the rules are successfully applied. I already heard the click on the inverter, so this means that our rules are working. And now we can see in the app that our output is already switched to the solar first, and the charger should be switched to the solar first, solar only as well. So basically this means that right now our microgrid started to use the solar power in this sunny day, and all our equipment which we are using for this live stream is also powered from the green energy. I think that is all about the software demo. I hope you enjoyed it, and I think you already noticed how easy it can be to set up the monitoring and control for your solar setup with Enapter module. So right now this is time for the questions. Yeah, I will go through the live chat and will address all of them. If you did not understand how the setup is done, so we have a QR code on the each module. So each module has a QR code which include the very unique device ID and information which is needed to encrypt the data between the devices. So when you scan the QR code, the mobile application starts to send the configuration over the wireless channel with the encrypted channel. Okay, Arna, thanks for the question. So My inverter is used for mainly for the outdoor lighting and on the house, as well as it used for security cameras and my internet connectivity. So only these things are connected to the solar inverter. Georg, can you please say what is USP? So what does USP stands for? So from the as I already mentioned, so most of the EMS, they have the same architecture as ours. But the strongest part of us is that we are not only targeting the integrators, but also we are looking how our end users and homeowners will use the energy system. So this means that we have a nice application. We have a very simple setup that in some cases homeowners can set up this automation themselves. So this is the most important advantage of Enapter EMS. At the same time, the integrators can use it for making a very complex and very complicated setups. So there is nothing changed at this part. Okay, one more question. As I mentioned, for advanced logic, we require the gateway. In this case, the integrator can use the rule-based engine on the gateway to set up very complex and nested logic. In our case, for this EMP RS-232 module, the logic is very simple and it's user-oriented. Therefore, this part is running directly on the module. You don't need gateway for this. Ayami, thanks for the question. The blockchain is not about the collecting the data, it's about to ensure the transactions. At the moment, we don't use blockchain for storing any data and ensure any transactions. But in the future, when there will be more microgrids, for sure the blockchain technology will be required to prove the transactions between the microgrids. So, for example, if there is exchange of the energy, in this case, the blockchain can be perfectly fitted. But for an Enapter energy management system, at the moment, no. Some technical problems. Yeah, so this is the first time we did a live stream. We would like to hear the feedback from you. Please leave the comments. And we want to know if this format is very useful or not. And if you would like it, we will definitely would like to try once again. And you are more than welcome to bring ideas which you would like to see on the next live video. Thanks for the question. Not exactly. So our EMS, as I explained it in the beginning, has many blocks. So the first important block is a universal communication module. So this universal communication module is pre-installed in our electrolyzers, and when you receive our electrolyzer, you will automatically get an EMS with the same functionality you have seen here to control and to monitor your electrolyzer. In case if you are using fuel cell, most of the fuel cells have integration protocols. So, for example, some of them have CAN bus, some of them have SNMP. So you can use one of our modules, like I don't have it here, but it looks like this, the same. So you can connect the fuel cell, and it will be automatically added to the energy management system, and you can set up the logic for our electrolyzer, fuel cell, and your inverter at one place. Douglas electrolyzer not in demo. Yeah, so there is no demo for electrolyzer today. So it was just about how to control the solar setup. But as I already mentioned for the previous question, the electrolyzer is managed the same way. The question from Lou, your EMS device can be purchased to be used in our system. Yeah, for sure. You can contact our sales team and yeah, discuss this. Hi, Paul. The question is there is a direct interface, the API, to Solar Edge inverter? Honestly, I'm not familiar with the Solar Edge inverter, but if it has some communication protocol, like for example RS485 or RS232, we can easily use one of our modules to do the integration. As I mentioned, we have the Lua SDK inside these modules, so the small script can be created to integrate it into our cloud and application. The question from Paul, how is the electrolyzer controlled modularity, parity load? Okay, so this is a very good question. So the electrolyzer can run on different production rates. So in general, you can set up the production starting from around 20% to 100%. There is few options for this. The one is to utilize the Modbus interface of the electrolyzer, or the second one is to use our EMS. So you can easily set up the rule which will depend on the weather conditions. So for example, if you will have the solar irradiance sensor, you can set up the rule to follow the production rate based on the current solar irradiance. And also for sure you can do this manually. So you're able to set your production rate just from the app or from the cloud. Okay, so the question from Vilas, would have loved to see the demo with electrolyzer in the demo system. Yeah, that would be great. Unfortunately, here in St. Petersburg at my home, I don't have electrolyzer, and because of lockdown, it's not so easy to travel to do the live stream with all equipment. But definitely we can do another live stream, the next one, from different place of the world to show you the demo with electrolyzer. So this is a good topic for the next live stream. So don't forget to subscribe. In this case, you will receive the notification about the next show. The question from Sebastian Justus Schmidt. So Sebastian is worried that I will have a sunburn. Yeah, most likely yes. So actually, I'm feeling how sun is spreading in my body. Okay, so one more question from Dmitry. How you add the support for new devices? Can I do myself? Yeah, so we have versions of the modules. Some of them, like for example, like this one, is a tank module. So it has a predefined functionality. So you can do much with this. So it's exactly done for the measuring the pressure in the hydrogen tank and the temperature, and use this data to understand how much energy you have stored in the tank. But we have the versions of these modules with a Lua customization SDK. In this case, you can use the API of our Lua customization toolkit and implement your logic for the module, how the data will be acquired from the connected devices to this module. And you can just upload it using our cloud. So first you set up the module using the QR code, and after that you upload your configuration. Question from Shelley. Interesting to see that the EMS gives the user more flexibility. Can it alert the user that there is a lot of sun, so he should turn his electrolyzer or leverage it to produce more hydrogen? Yes, so this is called monitoring rules. So using the gateway, we can set up the different rules to notify the user about any events. So for example, the events of some issues, or also some informational events. This is possible, yes. The question from Giorgio. Sorry, I lost partly your explanation. What is flexibility to accept other devices by Modbus RS-232, for example, a board of other appliances in the heating room? Okay, so what you need to do, you need to take our RS-232 module with a Lua SDK. Then you just scan the QR code of this module, and it is connected to the cloud. Afterwards, you develop your way of acquiring the data from the connected device. So actually, you implement the protocol, the communication protocol. So in case if in your heating room, I don't know, you have a boiler which is supports RS-232, you just implement this serial protocol in Lua, and you upload it to this module. And after that, the data is delivered to our cloud and also visible in our application. I don't know if I addressed the question, so if not, just leave more comments. I'll try to answer. The question from Lou, yes, so EMS can be purchased. You can easily contact our sales guys and discuss your needs, and yeah, so we can help you with this. The question from Dmitry, how soon Lua models will be available for purchase? So you can contact our sales team, so they're actually already in place. We will also leave the link for our satellite website for this particular case, for this solar inverter. So this is actually solarmonitor.enapter.com. So you can easily visit it and see the main features. Okay, so any more questions about the EMS or electrolyzer? So if you have some, maybe I can try to answer. If not, then I will say again, thank you for everyone. Also, thank you for everyone who supported us to make this live stream. So this is our team in St. Petersburg. I have my colleague sitting here who is doing all the technical things behind. Also the nice pictures which were done with our design team as well. And yeah, stay tuned, subscribe, likes, comments, and yeah, stay in touch. Thank you and bye-bye.